Hello everyone, my name is Liz Springer. My group members are Wyatt Curtis, Brady Dennis, Nick Rennick, Will Thomas, and Colton Thompson, and this is our safety controls presentation.
Safety features are built into the design of the process so that when equipment fails, the process can continue to operate. BPCS, or Basic Process Control Systems, use control loops to maintain this steady process in the event of a failure. And then alarm systems allow us to set off an alarm if the process is operating outside of its boundaries.
Next up is a Safety Instrument System, or SIS. This takes corrective action only if the first 3 layers of protection fail. These can shut down the entire process in some cases, so they're pretty extreme, but not always. After that are relief devices. These are designed to prevent a system from exceeding rupture limits, like a relief valves or rupture discs. After that is a physical protection, such as a storage vessel and anything else to physically keep any hazardous material away from anybody. And lastly are emergency responses. This is removing people from the premises after a fire or a leak of some sort.
The first feature of layers of protection that we chose to look at was PLCs. So in the Basic Process Control Systems layer protection, PLCs, which stands for Programmable Logical Controller, is an industrial computer that has been adapted for the control of manufacturing processes such as assembly lines, operating equipment, robotic devices, or any activity that requires high reliability and ease of programming. They're commonly used as a way of monitoring different pumps, motors, valves, and various different pieces of equipment. They can range from being small devices with only tens of inputs and outputs to very large devices with thousands of inputs and outputs. One way operators in manufacturing settings are able to utilize PLC systems is through the use of HMI or human-machine interfaces. So in my co-op experience, I worked at Certainty Gypsum, which is a drywall manufacturer. I worked as a process engineering co-op, and throughout the operating process, each individual area had its own HMI screen. So the dryer has its own HMI, the mixer has its own, etc. So, for example, the picture I have on the slide here is a screenshot of the HMI screen specifically used for the stacker tables, which is a piece of equipment used in the packaging area of the process, which stacks the drywall as a finished product to then be stored in the warehouse. And then through the HMI screen you see here, operators were able to easily make adjustments to the equipment and interact with the PLC system.
Safety Instrument Systems, or SIS, are a secondary set of controls meant to prevent or mitigate accidents. They usually remain inactive until a system parameter crosses a certain threshold, such as pressure getting too high or temperature getting too hot. An SIS may try to restore a system to its steady state, or they may completely shut down a process in order to prevent accidents. For my co-op, I was in a plastics extrusion R&D lab, where we had the feed and extruder controls hooked up to the same controller. This controller would measure the speed at which the extruder screws would turn and the force or torque required to turn the screws at that speed. It would also measure the pressure down at the end of the extruder where the discharge was. In the event of the extruder getting to too high a pressure or the screws receiving too much torque, where it could potentially damage the machine or create a hazardous situation that operator could be harmed in, there was a safety instrument system that would interfere and completely shut down our entire process. With the material feed and the extruder controls being hooked up to the same controller, the system was able to completely shut down everything in order to prevent accidents or the equipment getting out of control.
Our third highlighted layer of protection is alarm systems, and for this we're focusing on the ANSI ISA 18.2 guidelines. And before this was created, alarm systems were cluttered, chaotic, and often led to information overloads of systems for operators, because with the advent of computer control, it became very easy and cheap to add alarms to systems. And so this was created to form a national and eventually international set of standards for alarm management in industry.
Alright, for this next example, I'm going to quickly touch base on a project I did for Certainty Gypsum, where we cooperated with Simons to update our entire fire alarm system in the plant because it was going to be out of date and unsupported soon. That also included reworking a map that included evacuation routes and where the fire alarms all were for the plant-wide.
That concludes our presentation on layers of protection. Thank you for watching.